Well, Algebra 2 students, so my class just worked on these 3 problems as a warm-up, and then I think we just have one other little thing to do and you should be set for this assignment. So I think the first couple problems ask us to graph 2 different exponential functions, and they want us to do that using transformations, right? So, can you guys tell me, for k of x, is it growth or decay on this one? Growth? Should be growth. Oh, it's not going to work. So this guy, the 4, says that it's growth. And if you're watching the video, I'd really recommend that you try these first before watching it, so you might pause it now. What kind of transformations do we have? I believe there are 2. You guys can just shout them out if you like.
It's reflected across the x-axis.
Reflected, right? So this negative, is it outside or inside? It's outside, right? It's right in front. That's outside. The inside of these functions is actually the exponent. So this is inside. That's clearly outside, which means it's going to flip it down, right? So we've got a vertical reflection, or like Mason said, you can say reflected over the x-axis. That's fine. I like to just say vertical. Makes it easy for me. And then that 8. What does that 8 do with it? Left, right, up, down. It's inside, right? And it's plus, so it's left. Okay. So remember, when we start drawing any exponential function, we should always start with the asymptotic guide, the asymptote. So has this one's asymptote been moved, or is it still at 0? I think if it's been moved to left, that's not going to change the asymptote. If it's the originally here, it's just going to move it like this, so big deal. And reflecting it, I don't think is going to do anything. So I think the asymptote is still here. You always want to start with that guide and label it whenever you do any exponential function. And then you want to start with the next thing, which is usually it starts 1 above the axis, right? So there's no vertical stretch, which is going to change where that 1 above the axis would be. But there is a reflection. So this guy was going to be growth with the 4 growing upwards, right? But this reflection flips it down here. So instead of being up 1, it's going to be down 1 right there. Okay? And when I think that way, I really am still exempting myself from thinking about the left by 8. So that point was going to be there, but really it's going to be left by 8 over here, down 1. And growth was going to look like this, so when you flip it over, it's going to look like that. And there you go. There's a nice graph. Now I'm not going to take the time this time, but you always need to tell me 2 points. You go ahead and calculate the y-intercept over here and see how far down it is it crosses. Since this is an exponential function, base 4, this is going to be like a really steep kind of fall. So I'm guessing this y-intercept is going to be like thousands or even millions down on the axis. You don't have to find that one. You just have to find some other point. Okay? So make sure you label one other point. I'm not going to do it on this one, just to shortcut this video. Okay? So there's one. Let's look at one more. So this guy, beta. Is it growth or decay? Decay, right? This thing is the base. So the fact that that is less than 1 says that it's decay. And I think we have 2 transformations on this one as well. Can you guys tell me one of them or both of them? Down 15, yep. And the 10 is a vertical stretch. So we've got a vertical stretch here, down 15. Just for the benefit of those watching the video, I think I'll write that. Okay, so that should be enough for us to be able to graph. And this time we'll go ahead and plot 2 points like we're supposed to. So I'm going to do this. Why did I start by drawing my coordinate axes a little bit funky this time?
Because you were originally down 15?
Yeah, because I want to start by going down 15. That's where my asymptote that I'm going to start with is. So I'm just going to kind of pretend that this is 15. I'm going to label it. I'm going to think, okay, usually it's 1 above the axis. Is that going to be true for this one? This one would have been 1 above, but that 10 came in and stretched it out vertically, which means it's going to be like super steep, right? That last one, we had no stretch on, but 4 was already pretty steep. But anyway, on this one, the 10 is going to make it even steeper than the 1/2 would have led us to believe. So instead of being here at -14, where is it going to be?
5.
-5. Ooh. Close. I was thinking that was right, but I don't think so. Or is it? How can we check if we're not sure? Just plug it in, right? What is beta of 0? 10, 1/2 to the 0 power. Half to the 0 power is 1, just like anything to the 0 power. You guys were right. There you go. Okay, so if you're not sure, this is how you check. So we decided on a growth or decay shape. I think it was decay, right? And it was going to be steeper. So like 1/2 might have been like this, but the 10 is going to make it like crazy steep. You know what I mean? And it's hard to say exactly how steep, so maybe we'll plot one more point this time to see. So I'm going to calculate, I don't know, we've already got the y-intercept this time, so I'm going to go like 3. What's beta of 3? I'll use my calculator to do that. So 10, 1/2 to the 3rd. You guys should be able to do 1/2 to the 3rd. Isn't that 1/8? Yeah, so it's going to be 10 over 8. I guess this we could do it out of a calculator, but there it is with the calculator. -13.75. So if this is -15, it's kind of like about right there, right? And that kind of confirms what I was saying with how steeply this one was going to fall. So there you go, all right? Probably should label this guy too. Then you can clearly see your 2 points. Something like that, okay? So there we go. Last warm-up question I asked you to solve was this Algebra 1 question. It says, solve for the time and investment of 10 grand triples if you're investing it annually at a rate of 4%. Now, like I said, annual rates of investment aren't the way most investment accounts work, whether they're savings accounts or car loans or more complicated things in the stock market. But we're going to build up to being able to work with those kinds of interest rates real soon here. Okay, so we got to be able to start with something. So annual investments, remember, work like this. F of t, the principal amount of the investment, 1 plus or minus some rate of annual investment raised to the time. The principal we had here was 10 grand. I think it's growing, so we're going to plus 4% is 0.04 to the t. And what are we going to put over here if we're supposed to triple it?
30,000.
30,000. Okay, so that's going to be 10,000 times 1.04 to the t equals 30,000. So there's all kinds of ways to solve this. I think the best way is to do it algebraically, but we don't know logarithms yet. We're going to learn those tomorrow, so we'll be able to work a better way soon, okay? So we can throw this in our calculator right now. What's going to be the problem if we do that? I mean, it'll work, but the window's going to be explosively huge, right? Because of this 30 and this 10,000, and you're going to have to adjust it and mess with it. So what's a good first step? Maybe try to solve for t and just do the first step, Hayden.
Could you divide by 10,000?
Yes, that'd be the first thing we do to solve this anyway. And it's going to make, even if we do it graphically, it's going to make that a lot easier, right? It cuts it down to size, it's reasonable, and you get this. And by the way, you could have written this down before you ever did any of this, if you'd have thought about this problem and knew it a little bit better, because you could have said, okay, does it really matter what the initial investment is for this case? I don't think so. They just said triple it. So if I have one of my principals, here I want 3 of them. So really that says the same thing. We could have seen that to begin with. It would require more knowledge. Then how to solve this, we don't know until we have logarithms, so we're going to do it graphically. So we're going to come over here to our calculator and say 3. That's going to be y equals 3, a nice horizontal line. And there's our exponential growth function. There's 3. Here's our function growing to match 3. Looks like it's going to take longer than 10 years. So I'm going to go out farther. Maybe 20 years it'll get there, I don't know. Remember, this is tripling your investment. Is that going to be like a super small amount of time if it's only growing at 4%? You shouldn't expect it to be too small. It looks like a little bit longer than 20 years. Also, I want to see better, so I'm going to cut this down to 5. Just start right below. And let's go to 50 to make sure I see it. So you can see it a lot better if you cut out the extra fat, the extra stuff that's not useful for this problem, right? Now you can really see that spot very nice and clear. And you can calculate it by going left, right, yes. So the answer here we'd want to write in a sentence is that our investment of 10 grand will triple, according to this model at least, if nothing changes, about 28 years. Okay? So there we go. The one last thing I wanted to talk about today that you'll see in your assignment is a special exponential and logarithmic base. Now we're going to study this base over the course of this chapter. We won't really understand why it's special, maybe even by the end of the chapter, but hopefully we'll have an inkling about why it's special. I'll have you guys do a little background reading on it again. It's going to take probably till calculus to see how special this number is, but it's the second irrational number perhaps that you've encountered in math that pops up all over the place from here on out. This is the first time you've seen it. The other special number I'm thinking of, what's the other special irrational number you have worked with a lot?
Pi.
Pi, right? This one's just as important as pi. They're like the two big guns. Pi, I is pretty important actually. It's not irrational, it's imaginary. And E, they're all related to each other. So E, we're going to be looking at for the first time in this chapter. It's a special number, just like pi, and you need to memorize approximately what it is because it has no terminating decimal, but approximately it's 2.718. It's of course in many places on your calculator because of how important it is and how often you use it if you do anything with math or science. So for instance, can you guys tell me where is it on the calculator? Can you find it? It's in a few different places. Where is it, Jackson?
Above the division symbol.
It's on the division symbol? Yep. Anybody see it anywhere else?
Above ln.
Above ln, which is the logarithm that has it as a base, which we'll talk about starting this week. So if you want to see what it is, to more accuracy, there's what it is. If you remember it as 2.718, you're in good shape. So just like pi is 3.14159, etc., you should know this one. It's just as important. This is just your first time seeing it. So in this assignment, you'll have some exponential functions. For instance, what does regular e to the x look like? I think you guys should be able to guess what that looks like right now. You don't need our calculator. Is it exponential growth or decay?
Growth.
Growth, right? Because this is more than one. So if we don't do any transformations to it, then it's going to have this asymptote, just like any other growth function, right? And how far above is it going to start?
1.
1. Because e to the 0, 2.718 to the 0, just like anything else to the 0, even if it's a weird number, it's still 1. So it's just going to look like this. Kind of like 3 to the x would look. That's what e to the x looks like. The thing is, e to the x is this special, crazy, just right value of slope to do all kinds of really important stuff. It's like just the right slope, okay? And why it's just right is going to take a while to fully understand. But anyway, so you'll have some questions in this assignment that are like, okay, take a function like, I don't know, e to the negative x plus 6 and graph it. Take a function like, you know, negative 3e to the x minus 7 and graph it. And you're going to come over here and be like, okay, whatever. E is just like kind of close to 3. So I just pretend it's close to 3 and go with it. Okay? So I'll just do a quick sketch of each of these. So this guy transformed where? Up 6, and that reflects it. It's inside, so it's horizontal, so that's going to turn it this way. So I start with my asymptote, exponential growth, but that's going to flip it. So it's going to be like this. And that's way too flat. It's like 3, so it should be steep, but you guys get the idea, right? This guy, what transformations do we have on him? A stretch, a flip down this time, and to the right. So I don't think the asymptote has changed. This is really sloppy. Trying to do a slightly better job, but I'm just going for a quick sketch. Remember, on yours, make sure do a little bit better job than I'm doing here and have at least one other scaling point. So I'm going to go my asymptote, It was going to be up 3, but down 3. And the left 7 is really going to move that point, or not left, right 7. 1, 2, 3, 4, 5, 6, 7. Right there. Oops. Right there. So it's going to go like this. So there you go. Done. On this one, I think a good thing to do would be to calculate that y-intercept as your other point. Is it actually like -1 or so like me? I don't know. Here's a quick check. Let's see how bad I did. I think I did pretty bad. What's your question, Mason?
On f of x, would you classify that as growth or decay?
Mine's supposed to be much closer to the axis, right? This is supposed to be much steeper, so it's got to go. Not terrible, but he asked for this guy, technically, we're going to call this growth or decay. I think it's a hard question to answer. I don't think there's a technical answer to it. I mean, ultimately, isn't it decay? But we start by thinking as growth. So for you guys, I would be thinking this is growth that has been flipped. If you want to think about it as decay, you need to do what we did yesterday and say, how do you really think about e to the negative x? And like in my Calc 1 and 2 classes, we do this like every day. Things like this come up all the time. What's another way to think about e to the negative x? Help me. There's a hint. There's another hint. There's the other way to think about it. What's e to the -1 really mean? What's 2 to the -1 really mean? That means 1/2. So this means 1 over e. What's 1 over e?
Less than 1.
Yes, you got it. It is indeed less than 1, which is decay. Does that make sense? So, for most of you guys at this stage, I think it's better to go, oh, he is like 3, kind of. That's growth, flipped.